Here we have a graph of position versus clock time. Position S in meters, clock time T in seconds. The S for position and the S for seconds might be a little confusing, but that's not going to really affect what we're doing here. Okay, we want to interpret the rise and the run and the slope of this graph. So let's see what we've got. The run of the graph from here to here represents the change in the clock time from 3 seconds to 8 seconds. So that this run represents the change in clock time of 5 seconds. The rise of this graph represents the change in position from 4 meters to 10 meters. That's a change of position of 10 meters minus 4 meters, or 6 meters. The slope of the graph is the rise divided by the run, which equals 6 meters divided by 5 seconds, or 1.2 meters per second. Convention that I like to use is to put a rectangular box around a slope, and to put that slope near the segment whose slope is represented by that number or by that quantity. And in this case we see that the rise represents a 6-meter displacement of the object. The run represents a 5-second time interval. If an object displaces 6 meters in 5 seconds, its velocity averages 6 meters over 5 seconds, or 1.2 meters per second. Now that says nothing about the shape of the actual graph. This object could be moving at constant velocity, in which case its graph would be a straight line, and we would just have this segment as part of a straight line. Alternatively, the object could be moving at an increasing velocity, and the slope could represent just an average velocity between 2 clock times. The position versus time graph could be even more complicated. It could be the object could we could be going up on the graph and then down on the graph, indicating an increasing position, a positive velocity, a negative velocity, and then we could come back and go through this point. We really have no knowledge of what happens between these two graph points, but we can determine in any case what the average velocity is between the times corresponding to those two graph points.